We have a computer, sorry, connecting to some more computers, and the IP address is this, MAC address is this. By the way, what is the size of MAC address, Pavitra? Correct, 48-bit. Now, we saw even the routers got MAC address. On every port, there is a unique MAC address. Let's say this port name is Ethernet 0, and the MAC address on this is CCC, and IP address is 10.0.0.3. This is router 1. And we have a switch here connecting to a computer, let's say 50.0.0.1. MAC address is alpha, 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 and the IP address on E1, which is a gateway for this 50 network, is 50.0.0.2, and the MAC address is beta, beta, beta. Right, now, let's say we also have another computer which is gamma, gamma, gamma 50.0.0.3. And now alpha A wants to talk to B, which is A, this is A, this is B, and this is gamma, and this is alpha. Now A wants to talk to B. What will be the source IP address? It will be 10.0.0.1. Let's say it is pinging, okay? You go here and say ping 10.0.0.2. So the destination is going to be 10.0.0.2. Now what will be the source MAC address? A. Because it is local to the computer, this computer only generates this packet. So the computer knows its own MAC address very well. And it knows the destination IP address from the ping that you make. And it knows the source address because it's its own IP address. But what this PC do not know is the MAC address. To learn the MAC address of 10.0.0.2, yesterday I told you it will send an ARP request. I want to show you this ARP request in the real packet. A switch and then some computers. And I have connections to this device. And the IP address for that PC, I would like to give IP address. So the IP address that I want to give, I would like to write it here for your reference. or whatever. Okay. You can try this in your packet tracer later. But it won't be necessary. You just see what I'm doing. That's enough. It is just to show you the R packet. And on this router here, I'm going to give 192.168.0.3. This is the port name. All right, I'll start configuring this PCs first with the IP address. The first PC IP, as per the whiteboard behind us, it is 192.168.0.1. On the PC1. IP is 192.168.0.1. And the mask is 24. And the gateway is 192.168.0.3. That's the address of the router. You see, I have given this IP address, the mask, and the gateway. Likewise. And the next PC also, 192.168.0.2, 24. Gateway is 192.168.0.3. All right, what is next? I'd like to give IP address to the router. Now what I do, I say interface F00. You know these commands. I bring the interface up and I put the IP address 192.168.0.3. Mask is. On the router, we have to write subnet mask like this. But on the VPC, on the virtual PC, you just put like this, 24 mask. Oh, this is not the right mask. This is class C. Done. Okay. So now before I ping, what I do, I want to show you the ARP table. Show ARP. I see the MAC address of this router's F00 interface only. I don't see the MAC address of 192.168.0.1 and 192.168.0.2. So if you try pinging now, the router will first send R packet. It cannot send ICMP packet. Why? Can anyone tell me? When I say ping 192.168.0.1, the ping packet called ICMP will not be sent. Why? Because it do not know the MAC address, the destination MAC address which we are pinging. We are pinging 192.168.0.1, but the router do not know the MAC address of 192.168.0.1. So what it will do, it will provoke ARP. And ARP will send a layer 2 broadcast asking who is 192.168.0.1. Because it's a broadcast, it will go to every device connected to the switch. PC2 will ignore, it will receive, it will open, and then it will ignore because PC2's IP address is not 192.168.0.1. But PC1 will respond back because the ARP is about PC1's IP address. This is what I would like to show you. I'm going to capture the packet that is going on this red wire. This is a tool called Wireshark. Like a shark, it will bite the teeth. So with the teeth, sharp teeth, it will bite the wire and see what is going inside the wire, and it will show us. Right now, neither this router nor the PC, they don't have any ARP. But when I hit enter, behind the screen, you will see ARP request going. Are you all ready to see that? I hit enter. You see, immediately at the background, did you see? Before ICMP, what was going? ARP was going. And it was not a layer 2. See the source address. It is not a layer 3 address. It is not saying, it's not saying I'm coming from 192.168.0.3. Rather, it was showing the MAC address of the router, 0008, the last 4 number. You see, 0008. Router was sending a layer 2 broadcast. See, the destination address is a broadcast. The source address is the MAC address of the router, because I was pinging from the router. I was pinging from router 1. So it took the MAC address of the exit interface of the router as a source MAC address, and as a destination MAC address, it is using broadcast. If you want to see the broadcast address, open this. You see, destination broadcast FFFFFFFFF 12F, because MAC address is 12 hexa digit number. MAC address is 48 bit size. It is 12 hexa bits. When you write 48 bit in hexa, it's 12 hexa digits. And now all the bits are on. That's why you have FFF. That is what we call this broadcast. What is layer 3 broadcast? What is layer 3 broadcast address? 255, 255, 255, 255. What is layer 2 broadcast address? 12 times F. You can write layer 2 broadcast like this, or you can also write like this, FF4 F together and a dot. Right, both are same. Some operating system will group 2 by 2. Some will group 4 by 4. This is layer 2 broadcast. This is layer 3 broadcast. Now you can see here, because it do not know the MAC address, it couldn't send the packet. So it is sending a layer 2 broadcast. And if you open this, look at this, it says address resolution protocol request. And when you go down, you can see this is asking for this address. It says, I do not know the MAC address of 192.168.0.1. I'd like to know the MAC address of 192.168.0.1. If you see here, it will be very clear. Who has 192.168.0.1? Tell. Tell to whom? Tell to me. Who is me? 192.168.0.3. So the reply, this is the next packet, is the reply packet. It says 192.168.0.1 is this MAC address, 6800. See, it's a ARP reply, REPLY. You see, the previous one was request. Request is a layer 2 broadcast. A reply is not a broadcast, it's a layer 2 unicast. But it is a layer 2. ARP is a layer 2 service, it's not layer 3. ARP is layer 2. All right. Now, you are able to ping. You can ping. Check the ARP table now. Show ARP. You can see the MAC address of 192.168.0.1. Likewise, when I ping 192.168.0.2, you will find again another ARP coming now. Wait. Let me keep it ready and try pinging. See at the back, ARP request. After that, only ICMP can go. Who is 192.168.0.2? Tell to this. It learns MAC address. Okay. Now let us check the ARP table. You see, we got all three MAC address learned. Likewise, if you go to the PC, you will see now the MAC. What? Okay, you have the MAC address of the router. Let's try pinging from here to the other PC. 192.168.0.1. I'm getting a reply. And now if I check the ARP table, I'll have the MAC address of the other two devices. I have the MAC address of the other computer, but when I ping the router, I'll get the routers. Show ARP. Okay. Now let's go back to our learning here. So A is trying to talk to B. Ping is how it is trying to reach, but to ping, it needs the MAC address. Ping uses what protocol? ICMP. I showed you here, you see, ICMP. It sends the echo request. Open and see, it's an echo request. And the reply is coming, echo reply. All right. Now, ICMP, Internet Control Messaging Protocol, that's what ping uses. For ping, to send the packet out, it needs the MAC address, and it learns the MAC address through ARP. So now when the packet goes to the switch, switch has got what table? MAC table. In the MAC table, it says BBB is on this port. Let's say port number 2. AAA is on port number 1. CCC is on port number 3. So using the MAC table, it pushes the packet down here. Next. This time the packet is going to alpha. A wants to talk to alpha. Now what will be the destination address? Both MAC address and IP address. Can anyone try? Just try. I'm saying ping alpha. Alpha is 50.001. So the source address is 10.001. What is the destination IP address. .0.0.1. Okay. Now, what will be the MAC address of this packet? Let me tell you. The MAC address will be CCC. How? How? You see, in the computer, we give IP address and subnet mask. You remember, we also give default gateway. Why do we give? So that if this PC wants to send some traffic to some other network, I repeat, the PCs cannot send the packet to other network directly. So it will send the packet to router. If it needs to send the packet to router, it needs the address of the router. That is why we give default gateway. Remember in the homework, we forgot to give the default gateway. That's why we are not able to ping. And when we give the gateway, we were able to ping. See, whenever you are trying to reach different network, you need gateway. Only then you need gateway. If you are trying to ping between A and B, no gateway is needed. So what you said as an IP address is correct, but the MAC address will be the gateway's MAC address. How PCA knows the gateway's MAC address? Again, ARP. It will ask who is 10.0.0.3. The router will respond back. I am 10.0.0.3. My MAC address is CCC. So it puts the MAC address CCC here. And now, when the packet goes to the switch will read the destination MAC address CCC. It is in port number 3. So it forwards the packet like this. And now the packet has arrived on router 1. The packet is right now in router 1. Once it reaches router 1, it will check whether the destination MAC address is matching with its own. Yes, it is matching. If yes, only then it will uncover the packet. It will decapsulate and look into the layer 3. In the layer 3 header, it says the packet belongs to 50.0.0.1. Now routing table is used to know where is 50. The router maintains the routing table. In that routing table, what do we have? Routes. 10 network is on E0, 50 network on E1. Because the packet belongs to 50 network, a router now decides to send the packet this direction. Before sending, it needs the MAC address. So R1 will put the exit interface MAC address beta, beta, beta. Again, a router wants to know the MAC address of 50.0.0.1. So it will send a layer 2 broadcast ARP. And now this will respond back saying, I am alpha. Router 1 will learn it in the ARP table. I showed you this yesterday in the class, ARP table. Even the routers maintain ARP table. So now it knows that for 50.0.0.1, the MAC address is alpha. So it puts alpha and sends the packet to the switch. Switch knows where is alpha. It delivers the packet here. What I'm trying to explain you here is the MAC address will keep changing for every hop. But the IP address will never change till it reaches the destination. You see, without changing the IP address, only by using MAC address, The packet was going from computer A to router 1. We did not put the destination IP as 10.0.0.3, but the MAC address was CCC. That brought the packet to router 1. Once router 1 receives the packet, it looks into the layer 3 destination. It understands the packet belongs to 50 network. So it checks the routing table, learns that it needs to be delivered via E1. So it puts E1's MAC address as the source MAC address, beta, beta, beta. Source MAC address. But the destination MAC address 50001 is unknown. So it uses ARP. Even a router will send an ARP. It sends an ARP only in this direction, not in the other direction, because it knows 50 is in this direction. ARP reply comes, it learns MAC address. It puts that MAC address in the packet. Now the packet can be delivered here. You see? This MAC address, when the packet is received in alpha, the source MAC address is not the original MAC address of the sender. The source MAC address is the immediate router's address. But the source IP address is original sender's original address. So MAC address will change every hop. What is hop? Every jump. Every router is one jump. Every hop this MAC address will change, but the IP address will not. IP address is needed on every hop to know the final destination. MAC address is used to go to the immediate hop towards the destination. Is it clear? Any question? Is it clear? Okay. Now let us take 1, 2, 3. Now you see, when we ping from A to K, the source IP will be 10.0.0. What will be the destination IP address, Pavitra? Exactly, 50.0.0.2. What will be the source MAC address? What will be the destination MAC address? The gateway's MAC address, right? We configure gateway to the PC, right? 10.0.0.3. So it knows the MAC address of 10.0.0.3, which is CCC, correct? This you understood from the previous explanation, yes or no? Okay. Now the packet has gone to router 1. On receiving this packet, router will check whether this destination MAC address is its own. Yes, it is. Only if it matches, it will remove layer 2 and it will read layer 3 address. It says 50 network. Okay, 50 network is in this direction. So what it do, before it sends to the second hop. See, for this PC, this is the first hop, and this is the second hop. This is the third hop, and this is the final hop. Hop is a jump. Okay, every routing device is a hop. Every routing switch is not a hop. Every routing device is a hop. So before R1 sending the packet to R2, it will put the exit interface MAC address as the source, and it will put the next hop MAC address as the destination. So the packet now goes to router 2. It goes to router 2. In router 2, it checks the routing table, and before sending to router 3, it will put the exit interface MAC address and the next hop MAC address, which is router 3's MAC address. So the packet now reaches router 3. You see, in all these cases, the IP address never changed, but the hop, for every hop, the MAC address kept changing. When this packet is received on router 3, this HHS is matching with its own address, MAC address. So it opens and it learns that the packet belongs to 50. It knows 50 is in this direction. So before sending out, it puts the source as III, and using ARP, it learns the MAC address of 50002. It puts that MAC address KKK, and the packet is delivered to this PC. While receiving this PC, it checks the MAC address. It matches. So this PC understands that this packet belongs to me. It checks the destination IP that also matches. Oh no. Destination IP also matches. Then it starts reading layer 4, layer 5, layer 6 and start responding. You see, that's the final destination. So every hop, Pavitra, is a routing device. Every router is one hop. Okay. So can anyone try answering this question? How many times encapsulation, layer 2 encapsulation happened for this conversation? A is trying to talk to K. That's a conversation. Hey, come on. That's a conversation, network conversation. To reach K, there are a lot of encapsulation and decapsulation happened in the path. So I'm asking how many layer 2 encapsulation happened, how many layer 2 decapsulation happened. What about decapsulation? Vitra, you try. Priya said 3 encapsulation. I know why she said 3. Priya, you did not focus on the computer. The computer is also encapsulating and sending, right? You are saying 3, correct? On the router side, yes, 3. This encapsulated this address. This encapsulated this address. This encapsulated this address. But what about this one? PC encapsulated this. So 4 encapsulation. And how many decapsulation? 4 only. First, this decapsulated, this decapsulated, and then this decapsulated, and finally this guy is decapsulated. 4. So 4 times the layer 2 address got changed in the path. You know, when the final destination receives the packet, it won't receive the original source MAC address. It will receive with the immediate gateway's MAC address. The MAC address will be our own router's MAC address, but the IP address will be the original sender's IP address, right? Okay. So what are the questions you can expect from this topic you learned? One important question is this: why do we need two addresses? Why do we need MAC address when we have IP address? Or why do we need IP address when we have a burnt-in unique MAC address? Answer is this: IP address will help you only to show the final destination. But to move the packet to the destination, MAC address is needed. If you don't have MAC address, you will not be able to hop between the routers. MAC address is important to push the packet towards the final destination, what the IP address shows. So we need both the address. So question will be, why do we need to address? MAC address is permanent. Why you need IP address? That is how they will ask. And the answer is this: IP address, the layer 3 address shows the final destination. To that final destination, packet needs to go through multiple hops, multiple routers. To reach between these routers, to reach every hop, we need MAC address. Every hop, the MAC address changes. That change of MAC address only moves the packet to hops till the packet reaches the final destination. So we need both MAC address and IP address. LAN devices will use the MAC address and take the decision for forwarding port. Routers will read the IP address to decide the forwarding port. But both LAN and WAN needs IP address as well as MAC address for communication. It is very wrong to say LAN, we need only MAC address. No, you cannot communicate even inside LAN without IP address. We always use IP address to ping and to talk. The switch may not use IP address. It will use only the MAC address to switch the packet, but for communication, we need both MAC address and IP address in both LAN as well as WAN. What is WAN? Talking between different networks. In this scenario, WAN means talking between different networks. LAN means talking within the same network, within the same segment. Right?